There are cases when you'll need to find the percent of a number and then find the percent of that product. Multiple percents occur frequently, and in this video, we'll solve real-world problems of this form. Let's start with an example. A shirt that originally sold for $45 was discounted 30% for a pre-Christmas sale. As part of a post-Christmas sale, the shirt was discounted an additional 20%. What was the final cost of the shirt? This is an example of an item that is discounted once and then discounted again. The discount amount is the fractional amount discounted from the price, but what we want is the fractional amount left after the discount. So as a percent calculation, we are looking at this formula. The cost is the original cost of the shirt. The 1 minus percent calculations are for calculating the discounted price of the shirt, not the amount of the discount. Let's plug in values from the problem to find the double discounted price of the shirt. The original price of the shirt is here. The discounted price is found through this expression, and the double discounted price is found through this expression. We get 45 times 0.7 times 0.8 with a result of $25.20, which is the double discounted price. Notice that going from 45 to $25.20 is paying 56% of the original price. But that's the same as multiplying the individual percents, 70% and 80%. So multiple percents can be reduced to a single percent calculation. Let's look at another example. At the start of the year, a company stock price was $37.25. At the end of the year, the stock price increased by 28%. By the end of the following year, the stock price dropped by 17%. What was the stock price after the second year? This is an example that involves both a percent increase followed by a percent decrease. In this case, we need to multiply by a percent greater than 100 and then by one less than 100. This is the formula to use. In this formula, price is the initial price of the stock. The 1 plus percent 1 is the percent increase, and the 1 minus percent 2 is the percent decrease. Let's plug in the appropriate values. Here is the original price of the stock. This expression is the 28% increase in price, and this expression is the 17% decrease in price. We multiply all three terms to get this term. This needs to be rounded to the nearest penny. So the stock value is $39.57. Notice that going from $37.25 to $39.57 is a percent increase of 106.24% of the original price. But that's the same as multiplying the individual percents, 128% and 83%. So multiple percents can be reduced to a single percent calculation. Let's look at a final example. The price of gasoline went from $2.29 in one week to $2.57 in another week to $2.42. Describe the percent changes in the price. In this example, we are given the price changes but not the percent changes. We can use this formula to find the 2% changes, or the overall percent change. Let's look at the first price change. The price started at $2.29 and went to $2.57. We find the fraction change to $2.29 and multiply it by 100%. The result is about 12.23%. Now let's look at the second price change. The price started at $2.57 and went to $2.42. We find the fraction change to $2.57 and multiply it by 100%. The result is around negative 5.84%, reflecting a percent decrease. We now look at the 2% changes in one formula. This is the original price, this is the percent increase, and this is the percent decrease. The new price is $2.42, which is the desired result. Notice that going from $2.29 to $2.42 is a percent increase of 105.68% of the original price. But that's the same as multiplying the individual percents, 112.23% and 94.16%. So multiple percents can be reduced to a single percent calculation.